We'll continue with number 116 as well. All right, number 116 is f of x is a rational function, x squared plus 4 over x squared minus 4. What is the most outer operation happening? The quotient, right? You know, if you plugged a number in right now, you'd fill in everything. You would compute the numerator and denominator separately, and the very last thing you would do is divide. So therefore, the divide is the first thing the derivative encounters in a sense, and so the quotient rule is what will be applied first. So f prime of x will be this function with the derivative applied to the whole of it. But that will break down into the quotient rule, and so we'll have the bottom times the derivative of the top. So this tick mark is only going on the numerator expression now, right? Only going on this piece, not this piece. That's just the bottom plane. Minus top times derivative of the bottom. Same thing, this tick mark is only going on the x squared minus 4, not the x squared plus 4 on that term of the numerator, over bottom squared. So x squared minus 4 squared, and we will never multiply this out. I cannot even think of a reason why we would ever do that. You'll always leave this here. Matter of fact, sometimes you'll want to leave it this way so you can see if it will cancel with something above momentarily. But certainly right now, it will not cancel with this. That's just foolish. Even more foolish is that it's canceling with this, because this is not really x squared minus 4. This is the derivative of x squared minus 4. It just hasn't been accomplished yet. So these two could never cancel. And the only way that these two could cancel is if there was another x squared minus 4 over here, but there is not, and in general there will not be anything like that. Okay? So continuing with the derivative process, we now need to take the derivative within the quotient rule, which is these two. So applying what we did above for number 109, we know this derivative will distribute across this sum, because for the x squared minus 4, the most outer thing happening is the addition here. So for this one, the most outer thing happening for x squared minus 4 is the minus. So this will invoke the sum rule, and this will invoke the difference rule. Okay, a little sloppy there. All right, so we should have now, sharpen that pencil. Again, a lot of these will be extremely transparent as you get used to more and more problems. It becomes very visual, like I was trying to describe before. X squared minus 4. And then this will be, again, this is a bit much in terms of notation. This would be x squared, but just to show you exactly what's happening with these rules. Right? The derivative would apply itself to each of these separately, and you would add after the fact. Really, you would accomplish this in one smooth, this would just be 2x, right? This is just 2x, this is just 2x. But again, just to show the rules as explicitly as possible for these first few problems. But you would only want to write it like this at the very beginnings of your taking derivatives. I wrote a plus there, my apologies. This will become way too cumbersome as you work more and more problems. It will seem so unnecessary as you work more and more problems. And the bottom's the same, like I said. Don't mess with it. All right. So this is 2x, this is 0, 2x, and 0. All right, so let's knock those out there. So let's see what we have now. We have x squared minus 4 times 2x minus x squared plus 4 times 2x. And now it's just a matter of cleanup. All the derivatives have been taken. I have the slope of my curve right now anywhere sitting before me. It's just not in its best looking state. So very quickly here, 2x times x squared is 2x cubed. 2x times x squared is 2x cubed. but I'm subtracting them, so that's gone. I have negative 8x minus 8x of negative 16x. Again, the rest vanished, like I said verbally. So x squared minus 4 squared, there's our answer. There's the derivative for number 116.